Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous lecture we have talked about the adsorption as well as the absorption, and we have also discussed about the types of the adsorption, and based on that we are going to talk about the characteristics of adsorption. So what are the characteristics of the adsorption? Let us talk about that. So talking about the characteristic of the adsorption, the first point is that is it is a surface phenomenon. So this is what we have to know, that is adsorption is a phenomenon which is basically dependent on the surface, and that's the reason that it has been called as a surface phenomenon, unlike that of the absorption, which is basically a bulk phenomenon. And let us talk about the next thing, that is the concentration of the adsorbate is always higher on the surface of an adsorbent than in the bulk. For example, if any of the gas, so usually the adsorbate are the gas that are been deposited on the solids, and that solids are been considered to be, that is the adsorbent. So usually the adsorbate are been occupying the space on the surface of the adsorbent, and where we could see that most of the gases that are been accumulating on the surface of the adsorbent, basically they are present in more they are present in excess quantity on the surface rather than they are present in the bulk of the, that is adsorbent. So that's the reason that this is the characteristic that we should know. So not only radical, that is what we have given the example in various terms, we can also say that the atomic oxygen that deposit on the platinum or gold, so this happens. And there are also various gases, like we could say like carbon monoxide that deposit, or this gas that deposit on the tungsten filament. Or so in that case, these are the few examples that I was talking about. And in this case, basically what happens is the adsorbate, or basically especially the gases, so basically these gases, they occupy these spaces on the adsorbent, and this is what the second point is. And talking about the next one, that is it involves physical forces or chemical forces, because we know that adsorption are of two types, that is physical adsorption and chemical adsorption, known as physiosorption and chemisorption respectively. So they are involved with two kind of force of attraction between the adsorbate as well as the adsorbent. So one of is basically a physical force of attraction, or the physiosorption, and one is chemisorption. But meanwhile, they have a difference between them, and the one which depends on the properties also. And while talking about this thing, that physical forces, they bind with each other because of the van der Waals force or because of the physical force. While talking about the chemical force, like they form covalent bond, that is the adsorbate as well as the adsorbent, they form covalent bond when they are attached to each other. And there are certain characteristics that we are going to talk in the future lecture. So let us talk about this one, that is the next point, that is it takes place with the evolution of heat. Always when an adsorption happens, the evolution of heat takes place, unlike that of the absorption where no heat has been evolved. So therefore in this, basically in this kind of phenomenon, or in this kind of that is adsorption, basically the evolution of heat takes place, and it will depend on the type of the adsorption. But for a while we could understand that the evolution of heat takes place in the adsorption. So talking about the next point that we have, that is it depends on the pressure and temperature. Yes, it depends on pressure and temperature, and it has been observed that if more the pressure has been applied on the gas so as to be deposited on the adsorbent, then more the pressure, the more the gas will be accommodated on the surface of the adsorbent. So pressure is basically directly proportional, but at a certain range actually it becomes constant. And meanwhile we are going to talk about this later on also. And talking about the temperatures, so that how the temperature that affects on the accommodation, or how the temperature that affects on the adsorption. So as I've mentioned about this thing earlier also, that is if lower the temperature, then the absorption will be to a more extent, and if the higher the temperature, obviously we are making the gas to be deposited on the solid. So usually we know that if we provide more temperature, then obviously the gas will expand, and that won't be get deposited on the surface of the adsorbent. So temperature is basically inversely proportional, and we need low temperature, or the criteria for to give more good adsorption is we have to provide low temperature and high pressure, then only it will occur in a very nice manner. So this is the fifth point that we have discussed over it, but there are also certain points that we have to discuss, and that are the characteristic of the adsorption. And talking about the next one is, so talking about the next point, that is the adsorbed particles form multiple layers or multi-layers on the surface of the adsorbent in physical adsorption, and monolayers in chemisorption. Yes, even this is the main thing that we are going to talk about, and we are going to talk about it in deep detail in our next section also. So, talking about the adsorption particles, so the when it comes to that is physical adsorption, and physical adsorption, as we know that it forms because of the physical force of attraction between the that is adsorbate as well as adsorbent. So, physical adsorption can form multiple layers, and because of the van der Waals force of attraction that we know, and but talking about the chemisorption, but we have also discussed about the thing that chemisorption takes place because of the bonding or because of the chemical bond that takes place between the adsorbent as well as the adsorbent. So basically, monolayer is being obtained of that is of the gas, or we could say of the adsorbate that has been deposited on the adsorbent. So here there are the two differences that we have mentioned over here. That is the physical adsorption that can form multiple layer, while talking about the chemisorption, it will give a monolayer of the gas that has been deposited on the adsorbent. So that is the thing that we have discussed about in this one. And talking about the next thing, that is this kind of that is adsorption. It helps in heterogeneous catalysis. Obviously, that is when it comes to the heterogeneous catalyst, we know that the catalyst which is of different phase compared to that of the reactant. So in that case, we would get to know that this kind of reactions are basically very much helpful in the conversion of, for example, if I would say like conversion of an ethene to ethane, and in that case, basically ethene is a gaseous product, while the ethane is also a gaseous product. But meanwhile, the hydrogen that has been used, we cannot use hydrogen directly. So therefore, for that instead, we needed a ranenicle, and that ranenicle on which basically the hydrogen has been deposited. Hydrogen is basically of gaseous state. So the hydrogen which is of the gaseous state that has been deposited on the solid. So basically, this is the adsorption that takes place on the ranenicle, and now that ranenicle is being used in basically the hydrogenation of the ethene so as to form ethane. So that helps in the heterogeneous catalysis, and the ranenicle is also taking a part in basically acting as catalyst. So this is one of the few examples that I have talked about. So that's it. This were the characteristic of the adsorption that I was talking about. So thank you friends for watching this video. I hope you have understood this video very clearly, and you have got to know various concepts behind this one. And I hope you will share this video with your friends, and just don't forget to subscribe to my channel. Thank you so much.